the last class we discussed the properties. Now let us see some interesting patterns related to the square numbers. Now look at this triangular numbers. What is the meaning of triangular numbers? See, 1 is a triangular number, 3 is a triangular numbers. If you arrange the dots like this, the shape is looking like a triangle. 6 is a triangle number, looking like a triangle. So 10 is a triangular number. Then 15 also a triangular number. These type of numbers are called as triangular numbers. You can find out some more are there. So these triangular numbers, if you add, then you will get a square number. Look at this. Any two consecutive number you take. For example, 1 and 3. 1 is a triangular number, 3 is also a triangular number. 1 plus 3, it gives you 4. See, 3, triangle number, 1. So it gives you a square. 4 is a perfect square number. Once you add the consecutive triangular numbers, 3 and 6 are the triangular numbers. So as I said, 3 is a triangular number, 6 is also a triangular number. So if you arrange them, this 3 I am writing here dots, 1, 2, 3. This 6 dots here. So what you are getting? You are getting a square. Square number is 9. When you add the triangular numbers, you are getting a square number. Look at the 6 and 10. They consecutive triangular numbers. Here 10 numbers are there. Here we have taken 6. When you arrange this, it will give you a square number called 16. So what you can conclude from these examples? If we combine consecutive triangular numbers. Once you add the consecutive triangular numbers, you should get a square number. This is the first property you are getting. Okay, and it's a pattern. We are arranging the triangular number. So you are getting a beautiful pattern and getting the square numbers. This is the first one. Let's go to the second one now. Second pattern, numbers between the square numbers. So let us take some square numbers and identify the non-square numbers between the square numbers. What is the meaning of non-square numbers between the square numbers? See, 4 and 9 are square numbers. 4 and 9 are square numbers. Between these you have 5, you have 6, you have 7, 8. These numbers are called as non-square numbers. We call them as non-square numbers. So let us see how many non-square numbers are there between two square numbers. 1 square, 1 is a square number. 4 is a square number. Okay, 3 square. So between 1 and 4 you are having 2 and 3. Between 1 and 4 you have 2 and 3. Between 4 and 9 you have 5, 6, 7, 8. Between 9 and 16 you have 10, 11, 12, 13, 14, 15. Between 16 and 25 you have these many numbers. These are all non-perfect square numbers. Non-perfect or non-square numbers. We call them as non-square numbers. So let us see how many non-square numbers are there between the two consecutive. I have drawn a table here. Between 1 square and 2 square. 1 square and 2 square means it is between 1 and 4. Between 1 and 4, how many numbers are there? 2. So that 2 you will get by multiplying 2 into 1. 1 is this first number, first square number. 2 into this 1 gives you that 2. Now between 9 and 16, count how many non-square numbers are there? Between 9 and 16, how many non-square numbers are there? Between 9 and 16, 9 is a square number, 16 is a square number, 3 square and 4 square. Huh?
The 6 square number.
6. See, now multiply 2 to this 3, because it says 3 square, 3 square means 9, 2 into 3, 2 into 3 gives you 6, 6 non-square numbers are there. Between 4 square and 5 square, 4 square means 16, 5 square means 25. Between 16 and 25, how many are there?
Sir, 8.
8.
Sir, 8.
Multiply 2 to this one, 2 into 4. 2 into 4 gives you 8. 2 4s are 8. So that 8 is the non-square numbers, number of non-square numbers. Between 5 square and 6 square, so 5 square means 25, 6 square means 36. How many are there? How you will get 2 5s are 10? 2 5s are 10. Okay, now I will ask you, without this writing this, you have to tell me. Between 7 square and 8 square, how many numbers will be there? Okay. Between 10 square and 11 square. Between 10 square and 11 square. 20. Between 100 square and 101 square. Between 100 square, 200 numbers. This is between consecutive square numbers only. We are taking numbers between square numbers. Consecutive square numbers only we are taking. Consecutive square numbers. See, 1 square, 2 square, 3 square, 4 square, 5 square, 6 square, like that. Consecutively we are taking. So you got the formula to find the non-square numbers between two consecutive square numbers. It is 2 into n. 2 into now look at this. You have a formula. There are 2n non-perfect square numbers between the square number n and n plus 1. Square of n square and n plus 1 whole square. Between n square and n plus 1 whole square, you will get 2n non-perfect square numbers. See, another way also you can find out. I will tell you one more method. See, what is the difference between 1 square and 2 square? What is the difference between 1 square and 2 square? 1 square means 1, 2 square means 4. What is the difference between 1 and 4? 3. And minus 1 from this. 3 minus 1 gives you 2. Now what is the difference between 9 and 16? What is the difference between 9 and 16? 16 minus 9? 7. 7 minus 1 gives you? 7 minus 1 gives you? 6. What is the difference between 25 and 16? 25 minus 16? 9 minus 1 gives you 8. Now what is the difference between 36 and 25? 36 minus 25? 11 minus 1? 11 minus 1? 10. So there are 10 non-square. So therefore you can say in another way, see, number of non-square numbers is always 1 less than the difference between the two square numbers. It is 1 less than the difference between the two square numbers. Difference between, see, 2 square, 4 minus 1, 1 less than that 2, 16 minus 9, 7, 7 minus 1, 6, 25 minus 16, it is 9, 9 minus 1, 8. It is always 1 less than the difference between two square numbers. Example I have taken, 5 square minus 4 square, 25 minus 16, it is 9. So 9 minus 1, 1 less than that 1 means 9 minus 1, it is 8. There are 8 non-perfect square numbers between this 5 square and 4 square. So this is another rule you are getting from the pattern that we have seen there. Now third pattern, you look at this. We have third pattern.
Just show the class.
Look at this. Look at this pattern now. Adding odd numbers. Odd numbers addition only. You know what are the odd numbers?
Yes, sir.
1, 3, 5, 7. Okay. Now let us add these numbers. 1. It is only 1. 1 square. We are getting 1 can be written as 1 square. Add 2 odd numbers. Consecutive odd numbers. 1 plus 3. What it gives you? 4. It is a square of 2. Add 3 odd numbers. 3 odd numbers. First 3 odd numbers. 1 plus 3 plus 5. It is 9. It is square of 3. Add 4 odd numbers. 4. 1 plus 3 plus 5 plus 7. 16. 4 square. Add 5 numbers. 25. 5 square. Add 6 odd numbers. First 6 odd numbers. 36. 6 square. Now 1 odd number, 1 square. 2 consecutive odd numbers means 2 square. 3 consecutive odd numbers, 3 square. 4 consecutive odd numbers, 4 square. 5 consecutive number, 5 square. 6 consecutive numbers, 6 square. Now I will ask you one question. 100 is a square number. If you, how many odd numbers can be taken there together to get 100?
10.
So 10 odd numbers should be added there. So you can write 100 as sum of 10 first odd numbers, first 10 odd numbers, isn't it? 144. 144 can be written as sum of how many odd numbers? 12. 12. 400 can be written as 20 first odd numbers only. First 20 odd numbers. So this is the pattern you are getting from these examples. See, all the square numbers can be expressed as sum of the odd numbers. So that's the property we can write like this. If a natural number cannot be expressed as a sum of successive odd natural numbers. If you cannot express them as a sum of odd natural numbers starting with 1, then it is not a perfect square. All perfect square numbers can be expressed as sum of odd natural numbers. If you cannot express them as odd natural numbers, then it cannot be a perfect square number. So this is the property that we are getting by looking the pattern, previous pattern. Now we will go to another important. So this is sum of consecutive natural numbers. Here is a 3 square. 3 square is a square number. 9. You can write this as 4 plus 5. Natural numbers. Consecutive. 4 and 5 are consecutive natural numbers. 4 plus 5, 9. 3 square. Now 5 square. 25. 25 can be written as 12 plus 13. They are consecutive numbers. 7 square. Only I am taking odd numbers only. 7 square. 49. 24 plus 25. 9 square. It is 81. You can write this as 40 and 41. Sum of 40 and 41. 11 square. It is 121. You can write it as 60 and 61. 15 square. You can write it as 112 and 113. 112 and 113. How you will get these numbers 112, 113, 60, 61, 40, 41? Look at this 4 and 5. How you get? 4. This 4. You can write it as 3 square minus 1, 3 square plus 1. 3 square minus 1 by 2 gives you 4. 3 square plus 1. 3 is the number between 4 and 5. Or this 3. You can take this 3 itself. Okay. 3 square plus 1, 3 square minus 1. Sum of natural numbers. 5 square. 12 and 13, how you will get? 5 square plus 1 by 2, 5 square minus 1 by 2. Is it clear? What is 5 square minus 1? 5 square minus 1, what is 5 square minus 1? I can write 5 square minus 1 by 2. 5 5 is 25 minus 1, 24 by 2, 12. 5 square plus 1, 5 square means 25, 25 plus 1, 26, 26 divided by 2, 13. See, 12 and 13 I am getting like this.
26 by 2.
Okay, 13. Now same way we can write. Now you tell me this 60 and 61, how you will get, you tell me? 60 and 61. 11 square minus 1 by 2. 11 square plus 1 by 2. 121 minus 120 by 2, that is 60. This is 121. Okay, 122 by 2. So that is this is 61. 60 and 61. You got this pattern by looking these examples.
Yes, sir.
Now I will ask you one more. You write down 17 square. You write 17 square. 17 square. 17 square again. What you are writing? 140.
289. Sir. Sir, 145 and 146.
145 and 146. Is it correct? What is 17 square?
Yes, sir. Sir, 389.
389 plus 1 by 2. 389 minus 1 by 2 if you do, then you will get this. You understood this?
Yes, sir.
144 and 136.
140?
Sir, 145 and 146. Sir, 144 and 146.
What is 17 square? Look at this. 17 square plus minus 1. 17 square minus 1 by 2. And 17 square plus 1 by 2. So you do this. What is 17 square? 289 minus 1. 289 minus 1 by 2. 288 by 2. 144. It should be 144. Okay. Then 289 plus 1. 290 by 2. 290 by 2. What is that? 140?
Sir, 145.
144 and 145 is the correct answer. Okay. Then come to this next pattern here. Fifth type. All of you look at this. Product of two consecutive even or odd natural numbers. Even or odd natural numbers. So 11 and 13 are odd natural numbers and consecutive odd numbers. Immediately after 11 you are getting the 13 as the odd number. So once you multiply 11 and 13 you will get 143. 143 can be written as 12 square minus 1. 143. 12 square 144 minus 1. How you will get this 12? It is the number between 11 and 13. The number between 11 and 13 is 12. 12 square minus 1. See 11 and 13 you got 12 minus 1, 12 plus 1, 12 square minus 1. A plus b, a minus b to a plus b, a square minus b square. Now 13 and 15 can be written as, can you tell me directly? It is what is the number between 14 minus 1 into 14 plus 1. 14 square minus 1. Now 29 and 31. What is the number between 29 and 31? 30 minus 1, 30 plus 1. 30 square minus 1. Between 44 and 46, we have 45. 45 minus 1, 45 plus 1. Now I will give you one more number. 47 and 49. 47 and 49. 48 minus 1, 48 plus 1. Okay, 101 and 103. Suppose in the general form a plus 1 into a minus b1, a square minus 1. This is one pattern you got. Now let us go to some more patterns related to the square numbers. Square numbers. Here 1 square. 1 square is a square number. We can write like this one. 11 square. Expand 11 square. You get 121. 121. Property, that is square numbers related to this. Look at this now. These are all square number. 1 square 1. 11 square means 121. 121. 111 square 12,321. You can write 1 2 3 2 1. Look at this pattern. 1 1 2 1. 111 square 1 2 3 2 1. See 1111 square. It is 1 2 3 4 3 2 1. So this is 11,111 square. 1 2 3 4 5 4 3 2 1. Increasing then decreasing. Now if I ask you to find out 1 1 1 6 times, if I write, what you can write? What is the square of this number?
1
1 2 3 4 5 6 5 4 3 2 1. So look at this, a beautiful pattern with the square numbers having only digits 1 1 1 1 everywhere. So you can continue like this, you'll get a beautiful pattern like this. Arrangement of numbers, digits, a beautiful structure will come here. So now look at the same way, another pattern related to the square number. 7 square you can write 49. 67 square, it is 4,489. See 4 4 repeating 8 9. 667 square, 4 4 3 times 8 8 9. 6,667 square, 4 4 4 times, then 8 8 9. Like this. 6 6 6 7 square, here 4 5 times repeating, then 8 4 times 9, then 6 times, so we have 5 times 6 here. 6 6 times 4, 5 times 8, then last 9. Only 4, 8, 9 is repeating here. For 6, 7 like this if you increase, you are getting only 4, 8, 9, 4, 8, 9 only the digits repeating. So this is another interesting pattern related to the square numbers. You can find out many types of this square numbers with a beautiful pattern. Okay, so this is related to the patterns of square numbers.